So when all the amplifiers are going to be identical, they're going to have the same resonant frequency F naught. So this gain ratio will also be same for all the amplifiers. I hope you remember this expression which we derived yesterday. A by ARS. A is the overall gain of the amplifier for all the frequencies. And ARES is the gain at resonance, which is the peak value of gain at resonance. So if you cannot understand where we get this expression, see yesterday's class. See here this expression. We have got this ratio, right? So the same thing, I'm going to use it for studying the effect of cascading on bandwidth. See this expression and see this expression, both are going to be same. So this is for one amplifier. I have n amplifiers in cascade. So multiply this factor n times. So see here. So a into a into a, if you multiply n times, it will become a power n. Correct? The same number, if you multiply n times, it becomes a power n. So same way, see here. Now the gain of n stages of your cascade amplifier become the same ratio power n. See, actually, it is not power n, it will be product of individual expressions. But since all the amplifiers are considered to be identical, the gain will also be same. So it is just like multiplying the same number n times. So that is mathematically equivalent to writing it as a power n. So it is 1 by square root of 1 plus 2 delta QE the whole square, the whole power n. And square root, you know, it is power half. 1 power anything is 1. So 1 divided by, I can write 1 plus 2 delta QE the whole square power n by 2. Okay, I'm just eliminating square root and writing it in the form of a power exponent. Okay, 1 by this term power n by 2. We know how to find bandwidth. We'll equate this ratio to 1 by root 2. In the single tune amplifier, it is one stage. So I equated this expression to 1 by root 2. For an n stage amplifier, this is my overall gain. So I should equate this expression to 1 upon root 2. So equate this expression to 1 upon root 2 and find out the bandwidth. So I'm going to do that. See here, I'm equating this expression to 1 by root 2. And you should know why we are doing this. In logarithm scale, we'll be subtracting 3 dB. In numerical scale, it is equivalent to equating it to 1 by root 2, or you know 1 by root 2 value is 0.707. Some books refer it as points, they will equate to 0.707. Both are correct. Okay, so 1 by any term equal to 1 by another term. So I can equate denominators. Okay, so 1 by, so root of 1 plus 2 delta QE the whole square power n equal to root 2. So 1 plus 2 delta QE the whole square equal to 2 power 1 by n. Okay. So the square root and square root will get cancelled, because both sides you will have, this side you will have n by 2. This side you have 1 by 2. So the square root will cancel on both sides. So finally you have 1 plus 2 delta QE the whole square power n equal to 2, or 1 plus 2 delta QE the whole square equal to 2 power 1 by n. So bring this 1 to other side. So 2 delta QE the whole square equal to 2 power 1 by n minus 1. If you take square root, you will have plus or minus. So 2 delta QE equal to plus or minus root of 2 power 1 by n minus 1.